Okay, so this is the beginning of 5.4. Homework 19 is due Friday. Pause the screen, pause the video so you can copy all this down. Okay, so we have a log. Now, basically, the main thing we have to keep in, all we're going to do today is rewrite. Right now, we're just going to do a rewrite. So if it's a log, we're going to write it as an exponential, and if it's exponential, we're going to write it as a log. So we're used to seeing this. B to the power of E equals A. Now, in this example, B, what do you think B stands for? The base, good. I'm going to write that down just in case. Obviously, E is what? Exponent. And what do you think A is? Answer. Thank you. So when we're doing an exponential, we're going to take the base to the exponent to get our answer. But for a log function, the log, we have the base, we have the answer, and we're trying to find the exponent, okay? But before we start evaluating, let's just simply begin by doing a rewrite. So this number 1 and 2 and 6 are all log equations. If I were to write this as an exponential statement, it would be B to the power of A equals 140. That's the exact same statement. All I did was rewrite it, change it from a log statement to an exponential statement. For question 2, it would be what? How would I rewrite this as an exponential statement? 6 squared equals 36. Good. All right, now let's look at number 3. Number 3 is an exponential statement. Because we don't see the word log, that means we're starting off with an exponential statement, and we need to write it as a logarithmic statement. So it's going to be, first I'm going to start by writing the word log. The base of my log is n. The next thing that's going to come is the answer, which is after the equal sign, which would be m. And that's going to equal E, which is your exponent. So the log base n of m equals 5/6. That's how you would write that as a log statement. And I used to say, I mean, you know how some people say bay, like, oh, that's my bay. So here, log, see how we have BAE, base, answer, exponent. That's the order that we're going to go when we're writing a log statement. Base, answer, exponent. Okay. So number 4, I have my log. Now I'm going to put the base. Next is going to be my answer, and it's going to equal my exponent. That would be the way you would write number 4. Any questions so far? Okay, question number 5. We would write our log. Then I'm going to write the base. And then what's going to come next? 7.39. And what does that equal? 2. All right, let me pause for a second. Everybody look at your calculators real quick. Find the log key. Yeah. So everybody see the log key? The button right under it looks like an I, but that stands for LN, okay? Your calculator, let me go backwards. Let me do a little mini lesson off to the side, little mini lesson, just in case you don't know. Most calculators only have 2 log keys, okay? Some of the fancier ones have more. You have a log, which has a base of 10. That's your calculator. The base of that log key is a base 10. And then you have LN, which means a log with a base of E. Have you all heard of E? E is a constant used in math, kind of like pi. Pi is 3.14. Well, E is like 2.72. All right, it's used a lot in science, okay? So if you have a log with a base E, because it's used so much, we just call that a natural log. So that's what this is. This is a natural log that's used a lot in science. This first one is a common log. Okay, so those are the two buttons that are on the majority of the basic calculators. Now, there are some fancy calculators that you can do any base log. But for the majority, you can only have a base 10, which is a common, and a base E, which is a natural log. Okay? So the reason why I say that is that when we go back to number 5, notice how number 5 says log with a base E. Now, whenever there's a log base E, we have to change it. So what did I say log base E really represented? ln. So I'm going to write this as ln 7.39 equals 2. And that's really important. So if you have a log base 10, we can drop the 10. If you have a log base E, we have to switch it over to a natural log. Now remember, number 6 doesn't say the base. But what do you think the base, what did I just tell you the base of a natural log was? E. So whenever you see a natural log, this is really a log with a base E of 5 equals 1.61. That's what that really is saying. So when I write it as my exponential statement, it would be E, and what's my exponent? 1.61 equals 5. And it's really not an equal, it's approximately equal. All right, so let me go ahead and zoom out. So all we started off doing was just doing a rewrite. We rewrote the logs as an exponential, and then we rewrote our exponentials as logs. Any questions about those first 6 questions? Yes. Yes, the passage should be on my desk, I believe. All right, so now let's go ahead. I'm gonna give you a couple minutes. You've already written this down. You should already have this down. Now go ahead and write this down, and we're going to practice evaluating. Evaluating is figuring out what is the power. Maybe it's not here. Ooh. Do you have contact solution? Do you have contact solution? I used to have some. Do you use like a certain kind?
I usually use my drops, but I'll just
Let me see if I have some. Okay, so what this is asking us for, whenever you see the word evaluate, it's asking us what is the exponent. So for that first one that I have highlighted in 3, the way you would read this in words is 3, because that's my power, or my base, I'm sorry. 3 to the exponent of what equals 81. So if I were to do a rewrite, this would be 3. I'm going to equal it to A. 3 to the power of A equals 81. And then you would just have to figure out, what is my answer? What is the answer? What is the exponent that I can attach to a base 3 to get 81? How many times you have to multiply the base to get 81? So the answer would be 4. So for this example we started off with, the log base 3 of 81 is 4. Okay, you don't have to do a rewrite, but I do find it's kind of helpful for when students do. So what I'm going to do is I'm going to rewrite this as 7 to the power of what equals 49. Don't say it out loud, but see if you can figure out what is the power. What is the missing exponent? As a matter of fact, I'm going to rewrite this whole row, and I want you all to take a couple minutes to answer all 3. So we have 7 to what power is 1 over 49. And then I have 3 to what power is 1. So I'm going to let you all take a couple minutes, see if you can answer those 3 questions. The quiz average was 85 point, oh wait, sorry, that's not yours. 89% average in this class. 89%. Great job. 89. So I will show you yours on Wednesday. You all had the highest average. It was almost an A average, which is really impressive. All right, so what do we think our answers are? So for my first one, number 1, what's the exponent that I need to attach to the base of 7 to get 49? 2. Who agrees that it's 2? All right, for number 2, it's 1 over 49. So that means that it's not a positive 2, but it changed to a negative 2. Good job. All right, last one is tricky. What's my exponent? 0. Any base to the power of 0 is 1. Good job. All right, let's keep on moving here. So now we're going to solve a few exponential equations. And we're going to start by, so I'm going to give you a second to copy these 4 down, and then we'll go through them together. let's go ahead and look at these together. So sometimes you'll have to just do a rewrite, okay? And then sometimes you'll have to just solve. So how can you tell the difference? When you don't have a full log statement. So do you notice that on this side, I don't have my answer? All right, they gave me the base. Sorry. Yeah, they gave me the base, but not the answer. So for this one, all you would have to do is do a rewrite. So if I were to rewrite this as an exponential statement, it would be 2. What's my exponent? 4 equals x. So remember, it's log, and then it's base, and then you have your answer that equals your exponent. Okay. So now we just figure out what that is. What is 2 to the power of 4? Is it 8? Because 2 times 4 is 8. 16. Same thing with number 2. Notice I don't have a full statement. This time they gave me the answer, but they didn't give me a base. It's not a complete statement. So we also would need to do a rewrite. So how would I rewrite this? X to the power of -3 equals 1 over 125. So now I need to figure out what's my base. What base to the power of -3 equals 1 over 125? 5. Good job. But now when we get to 2, I'm sorry, not 2, but 3, we have a full statement. If you have a full statement, then we're going to start by evaluating that statement. This is what I'm going to do first. I'm going to evaluate the statement. Okay? If I have a log statement and I know my base and I know the answer, then I can evaluate it. So what that is asking me for, that log base 2 of 8 is saying 2 to what power is equal to 8? So we have to answer that first. Then we can go back and solve the equation. So what would be my missing exponent? 2 to what power equals 8? 3. So I'm going to rewrite this as 2x minus 7 equals 3. Go ahead and solve it. You would add the 7, divide by 2. Oops. I don't know what I just hit. Okay. So we would add 7. Divide by 2, and we should get x equals 5. Who got x equals 5? Okay, good. Same thing with number 4. See, we have, this is a full statement. This is a full statement. I just need to figure out what is the answer. All right, if I have, you need to have 2 things for it to be a full statement. You need to have the base and the answer. So we have a full statement, so I'm going to start by evaluating it. So that's what I need to do first, is I'm going to evaluate this, which means in order to evaluate it, I need to figure out 3 to what power is 1 over 81. So what is my power? 4 or -4? I heard -4. So now that I have that, I can substitute that in. So I know that -4 is going to equal 1/2 x plus 2. And now we need to solve that for x. So I'm going to start off by subtracting 2. So negative 6 equals 1/2 x. And then to get rid of a fraction, I'm going to multiply both sides by the reciprocal. Matter of fact, let me give myself a little bit more space. That's the easiest way to clear a fraction, in my opinion. And what's the opposite, or not the opposite, what's the reciprocal of 1/2? 2. 2 over 1. So I'm just going to multiply both sides by 2. That's going to clear out my fraction. And then I'll have 2 times negative 6. And my answer would be negative 12. All right, questions about these first 4 equations? What y'all think? Thumbs up, sideways, down. Where we at? First day of logs. You know, we always start in the kiddie pool, right? The water be at our ankle. Then we slowly go to the other side. All right, almost there. Go ahead and copy down these 2 equations. Okay. So again, we're going to start by asking ourselves, is it a full log statement? Let's look at the log. In order for it to be a full statement, I would need to know the base and the answer. Clearly, I don't know the answer, right? Because this answer has a variable. So what I'm going to do is do a rewrite. Okay, if it's not a full statement, we do a rewrite. So this would be 9 to the power of what? 0. Yes, so this is still, let me go back. This is still your base. This is still your answer. And this is still your exponent. That does not change. It doesn't matter that now we got some x squareds and stuff in there. That does not matter. So let's do our rewrite. It would be 9 to the power of 0 equals 3x minus 8. That's how you would write that out. And we've already established what? That any number to the power of 0 is 1. Go ahead and solve it from there. So I'm going to add the 8, and then I'm going to divide by 3. So who got x equals 3? All right, same thing for number 6. Even though we got x squareds in there, this is still your base. This is still your answer. And this is still your exponent. Okay, so we're going to do what? We're going to do a rewrite. So when I rewrite it, it's going to be 5 to the power of what? 2 equals x squared minus 4x plus 4. Which is going to be 25 equals x squared minus 4x plus 4. It's a quadratic, so we need to set it equal to 0. And what's 4 minus 25? Negative 21. Let's go ahead and factor that down and set them equal to 0. So this time we'll have 2 answers. So we need 2 numbers. It has to multiply to give you negative 21 and add to negative 4. 7 and 3. Which one would be negative, Javay? Negative 7. Good job. Last step, set both of those equal to 0. So my 2 solutions would be 7 and negative 3. Now, we're not going to talk about it today because I had to switch my little lesson around a little bit because of, things. But we are going to talk about graphing. Now, logs don't have a domain of all real numbers. Exponentials do, but not logs. So we can have extraneous solutions, okay? And we'll talk about that a little bit. We'll talk about that on Wednesday. All right, last 2. We're going to just last 2 and then we'll be finished. So go ahead and copy down these 2 and we're just simply going to simplify them. Okay, so this one looks kind of complicated, but I wanted to make sure we understood what was happening here. So all we have to do here, these are all complete statements. Would you agree? We have 3 of them. We need to evaluate each one individually. So we're going to start off with this one. 4 to the what power is going to give me 16? 2. All right, so that's going to change to a 2. Bring down the addition sign. My next statement. We got to figure out 3. 3 to the what power is 27? Show me with your fingers. What would be my exponent? Yep, 3. So I'm going to make that a 3. Bring down a subtraction sign. All right, now we have our third statement. 2 to the what power is 1 over 32. Now we know it's negative, right? But negative what? 2 to negative what is going to give me 1 over 32? Negative 5. So from here, we would just do the math. Because these are all numbers. Every single last one of these are numbers. We had to figure out what the numbers were. So we know when you subtract the negative, right? What is going to happen with these two? Because it's going to become a positive. So we would have 2 plus 3 plus 5. And my final answer would just be 10. All right, let's do our last one. Again, we have full statements here. So this is my first statement. 3 to the what power is 81? 4. Okay. Bring down the subtraction sign. Okay, this is tricky. 2 to the what power is 1/2? Negative 1. So that's going to be minus a negative 1. Then it says close your parentheses. Start a new parentheses. Now last one. 5 to the what power is 25? 2. Okay, so we're just going to add these together. So that would be a 5. And 5 times 2. Well, look at that. We get 10 again. All right. Now, tomorrow is an e-learning day. Okay. You do need to log on. If you look on our Canvas page, at the very top, it says click here to join the class. And it's a modified schedule. So first period starts at 8. And every class is 24 minutes. So this class starts about 8:24, 8:27, something like that.